How do we heat our homes without oil and gas? The challenges are considerable. There's a limit to renewable fuels like wood pellets. The great hope for the future, so-called green hydrogen, is still exorbitantly expensive. And solar collectors will never generate enough heat in Germany in the winter. These renewables can only provide a small part of our heat supply. Therefore, we must use electricity from renewable sources for heating our homes. This is the only way to make them climate neutral. But if what is known as green electricity is converted directly into heat, the demand for the 40 million homes in Germany would be enormous. Roughly 100,000 wind turbines would be needed to supply electricity just to heat the houses, more than 3 times as many turbines as are currently installed in this country. In the city of Viersen in the far west of Germany, an old apartment building is heated with heat pumps powered by green electricity. In addition to electricity, heat pumps use the ambient heat in the vicinity of the house. Andreas Kamps would like to significantly reduce electricity requirements in this way. Heat pumps would also lower the heating costs, of course. These are all the additional expenses that play an important role for tenants in properties like this. Andreas Kamps has done extensive renovations. The apartment building was built in 1907. In the future, the 7 apartments will be supplied with heat created completely without oil or gas. The heat pumps use the environmental heat of the subsoil. Several holes are drilled directly next to the building in Viersen, down to a depth of 100 meters. At this depth, even in winter, there are constant temperatures of between 10 and 20 degrees Celsius. Since the heat from the summer is preserved below ground. A water glycol mixture absorbs the heat stored in the ground via a downhole heat exchanger. The heat then flows back to the surface via pipes. Since a borehole is drilled for each apartment, 7 pipes are connected to the basement with the water glycol mixture, which is also known as brine. This brine flows with the heat from the basement up to the individual apartments. An old chimney is used for this purpose. A heat pump is installed in each of the 7 apartments. The pumps not only ensure a pleasant room temperature, but also heat the water for the showers, for example. Since this heating is not done centrally in a large storage tank in the basement, but directly in the heat pump, the water does not have to be heated to over 60 degrees Celsius, as is usually required by law in Germany for drinking water. This allows the heat pump to work even more efficiently. The brine absorbs heat from the ground. The brine then transfers its energy in the heat pump to a special refrigerant via a heat exchanger. This refrigerant evaporates at a temperature of around 8 degrees Celsius. The gas that arises during this process is then compressed, which makes it incredibly hot. Electricity is needed for this. The gas then transfers its heat in another heat exchanger to the heating circuit in the apartment. It condenses in the process and flows through a throttle valve back to the outside for evaporation. This is how the large amount of heat from below ground is raised to a higher temperature level with the help of electrical energy. The heat pump works particularly efficiently when it generates a lot of heat with as little electrical energy as possible. For this, the heating temperature, that is, the temperature of the water inside the heating system, must be as low as possible. and that requires the largest possible heating surfaces. This means that heating systems with a large surface area can significantly reduce electricity requirements, like this wall heater, for example. Here, the heating water flows through the plastic rods that can be plugged together to any size and then integrated into the wall with plaster about 3 centimeters thick. Underfloor heating systems also offer a large surface area. They can also be retrofitted in older buildings. This lowers the overall heating temperature and ultimately increases the efficiency of the heat pump. This system is really great. The floor is now 4 centimeters higher than it used to be, max. And when it's just 4 centimeters, we can use normal screed, and it weighs less than 60 kilos. When you're working in older buildings, you very often have wood beam ceilings where you just can't put a higher load on it. And the great thing is that, as you can see here, I can put it on the floor that's already there. You just have to shorten the doors a bit. Then you have a new underfloor heating in an older pre-existing building. When laying the pipes, make sure that the space between them is only about 8 centimeters, about half of conventional underfloor heating. This increases heat transfer, reduces the overall heating temperature, and increases the efficiency of the heat pump. Both floor and wall heaters provide a large heating surface, which means low heating temperatures. But ceiling heaters are also up to the task. These can be installed on the ceiling with a depth of just 3 centimeters, and then sealed up with sheetrock. They can also be installed in older buildings without major renovations. And there's a pleasant side effect. All panel heating systems also enable efficient cooling in the summer. In the apartment building in Viersen, underfloor heating was installed during renovations. The total height, including sound insulation, is only a few centimeters. Underfloor heating systems usually have so-called individual room controls that allow you to set the temperature individually in each room. The individual room control is made from components that tend to break over the years. Plus, they need electricity, and we want to be energy savers, so we leave out everything that gobbles up more energy, which is why we don't use individual room controls. They also cost between 1,200 and 1,500 euros. I don't need them. The ideal temperature of an apartment in the building in Viersen isn't constantly readjusted in the individual rooms. It's set once using precise hydraulic calibration on the valves of the heating circuits. This means that the temperature of the heating water is the same for all rooms. However, to allow for different temperatures, in the bathroom or the bedroom, for example, hydraulic calibration determines the amount of water that flows through each room. So significantly more water flows through the valve for the bathroom within a minute, through the pipes laid on the floor, than in the bedroom. The heating water never exceeds 35 degrees Celsius. The temperature of the water flowing back is constantly measured. The system knows at any moment just how much heat has been absorbed and can then readjust the temperature of the water flowing into the rooms on a whole if necessary. Such precise management of the underfloor heating is incredibly efficient. As a result, the heat pump generates 4.5 kilowatt-hours of heat from 1 kilowatt-hour of electrical energy. This means that for an average household, future tenants will need around 1,000 kilowatt-hours of electricity per year to supply heat for a 100 square meter or 2-bedroom apartment, including hot water. The old apartment building in Viersen not only has a beautiful view, but also very low heating costs. Every second household in Germany is located in an apartment building. Many of these buildings were built several decades ago, some over 100 years ago. This building in Filzen is one example of how heat pumps provide climate-neutral heat to old structures while preserving their character. Green energy is used efficiently, utility costs are reduced, and all that without oil or gas.